Welcome to another session, Data with Nikk the Greek. Finally, we're gonna start with a new series, Loading Big Data Efficiently. I'm actually really excited about it. Loading big data efficiently, of course, doesn't work without understanding different data formats, because the data format has also like a big influence on how efficient we can load data. So the idea of the series is that today in part one, we start a little bit blindly observe how different data formats behave in action. And then in the next part, we can understand the architecture and how the different data formats we evaluate today work conceptually. And then the next parts, we're gonna start with different approaches and methods to load those different data formats more efficiently with Spark. So that means for today, we basically gonna focus on four formats: JSON, a semi-structured format, and CSV, a comma-separated format. So they're both human readable. I don't wanna say more secrets right now, but I guess with CSV and JSON, you already had some touch points. And then we have more big data focus formats, AVRO and PARQUET. And today we're gonna focus on three things. So doing our evaluation, we're gonna take a look on the size, the saving time, and the load time of those four formats. And with that, let's get started and jump into VS Code. All right, so let's have a look first of all on our data set, which we're using today. I created here a small generator, which generated me 10 million rows. And basically the data set is quite simple. We have an integer or begin column, which is an ID. Then we have a date and a timestamp. And then based on some random logic, I just created some string columns based on this ID integer, just to generate some data out of it. And based on this data set, let's jump straight away into your first data format. So we have JSON, and we see, okay, when I'm executing the write, it takes 6.6 seconds, and then when I'm loading it, 11.7 seconds, and the data size is 1.2 gigabytes. And what I didn't tell you, I also created, so a little bit more technically, 8 partitions out of the data set. That means also that we have 8 files at the end which cannot be saved. So let's have a quick look here. So Spark is using Hadoop in the background to save the data. And then port and find is this here. Those are just some checksum files and the success file, which marks that the saving has been performed successful. So here we have 8 files, and also when we're gonna check, we're gonna do it now once for JSON. The first step, we also see here 1.18 gigabyte, which are those 1,208 megabytes. As each file is bigger than the 128 megabytes max partition bytes, I also increased here the Spark SQL file max partition bytes. It's basically based on how much each file is allowed to be loaded into one Spark partition. That's only for a fair comparison. If you don't understand this at this stage, I'm gonna link a link below here in the video where you can deep dive and understand a little bit more how this configuration works. It's just for a fair analysis and comparison of the performance. So that means here we remember we have 1,208 megabytes for now, which we loaded. So now let's go to CSV. Right, the load time is similar, but the data size is already half the size as we had before. Then for CSV, there are also two options. You also have an inference schema options. So we're gonna see it in a bit in the Spark UI. So what Spark generally is doing, it just checks the first row to interfere the schema, but you can also let him search the whole schema so that you're gonna have a more accurate schema loaded for your data. And when we're doing that, so loading time and data size, of course, is the same. Saving time is the same, but the loading time, of course, increases significantly. So 5.3 seconds versus 2.3.5 seconds. Now let's come to our big data formats. And here we see, well, a significant difference. So first of all, Write time is not significantly faster, but the loading time for Parquet is significantly faster, and the data size as well. So 80.1 megabytes versus 593, or versus 1024 megabytes, what we had before. And that's like, I think I calculate a factor of 16 or 17, which is smaller. And so, of course, if you're on cloud storage or file storages where you have terabytes of data, saving factor 10 is a big deal. Usually file storage are not that expensive, but still you would like to use those 200, 300 or 3,000 euros a month, depending on the size of your data, of course, for other topics. So then let's have a look on our last file. So we have AVRO. AVRO is interesting. So data size is not significantly smaller, so around 10% or 12%. But the write time is faster, so half of it, but therefore the load time is maybe 50% slower compared to Parquet. But both formats seem to perform way better than the other formats. So let's summarize this shortly. I create a small table to just see the comparison. So we can see JSON 1208 megabytes versus 80 or 69 megabytes for AVRO. And write time wise, no significant differences except of AVRO. So AVRO seems to perform very, very well and fast when writing data. And then loading time wise, CSV without interfering the schema is quite close to Parquet and AVRO, but Parquet, even when loading all data sets, seems to be highly performant, and also AVRO is not much slower here. So one thing I talked about before we're gonna jump into the Spark UI, we also talked about schema interference. And when we're loading the data, we also want to check, okay, is the schema loaded correctly? So here I printed the schema of the initial data set. So we have a big int, a date, a timestamp, and then 3 string columns, as I explained before. And now we're looking on the CSV format without interference. And then we see, okay, all the columns seem to be loaded as strings. So that's, of course, totally wrong. If you do the schema interference, it looks already a little bit better. Here it's not a big int, but an int. And then we have here date and timestamp, but our numbers, which are, well, saved as strings. So that's why I did this tweak to see what's happening there, are then suddenly understood as integers. When we are looking at JSON, so here the order is a little bit different. So we have here the big int correctly identified, and our ID first, last, and string are identified correctly as string. But dates and timestamps, JSON seems not to understand those formats. So they are basically defined as strings there. And then we have Parquet and AVRO. Let's see if we can manage this on the screen. So here we can see big int, date, timestamp, string, 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 and here the same. So Parquet and AVRO seem somehow to really well understand or potentially save, you only make observations and assumptions here, save the schema format. And that's also like a really good benefit because you don't need to interfere to define a schema later on by yourself. Now let's have a look into our Spark UI. And let's start again with JSON, and let's evaluate a little bit what's happening during the load. So in the Spark UI, you see that we have 2 jobs during the load. So we have here 4 seconds and then 7 seconds. And what's important here is, so we can also have a look here into the code shortly in the Spark GitHub repository. What's written here is the function goes to the input once to determine the input schema. And that's where the first job is coming from. So we have one job which is going through all your data to interfere the schema. It works not too bad, as we saw. And then we have another job to actually load the data. So basically, we have 4 seconds metadata loading, roughly said. So schema in this case. And then we have 7 seconds to load the actual data. And a similar thing actually happens here with CSV. So here we have 2 jobs for the CSV. And if we're looking again here in the description, what it says is if the schema is not specified, this function goes to the input once to determine the input schema. So, and if we don't use interfere schema, it goes only through the first line. And that's exactly what's happening here. So we have here a very short job, interference. If you're gonna go here into the stage and then to the task, we can also see why or how to see the one line. So we see it already here, 68 kilobytes and 1 record. I'm not sure why the Spark UI doesn't bot yet. And you see here, so we loaded literally 1 row to interfere the schema. And that's basically what's happening here within 45 milliseconds. And then the actual loading of the data takes 5 seconds in this case. And I mean, this is of course, quite fast, but the schema wasn't really well. So now we have here a similar situation. But now we have the infer schema and suddenly we have 3 jobs. So what the first job is doing, we see it also in the fast execution time in one stage. It does exactly the same. It interferes the first row. I don't know why it's needed if you have infer schema anyways. Then we are loading the metadata and then we load the data itself. I'm surprised that that here suddenly the loading of the actual data is also bigger. But probably the application of the schema might require some more loading time. And then let's continue, have a look onto loading Parquet. So here we also surprisingly see again 2 jobs. So of course the job here is not, well, not of course, but so we can see that the job is not as long as, for instance, for CSV or for JSON, where it took multiple seconds. Here it takes also 98 milliseconds. So that means that the schema interference here is quite efficient. And we're going to see in the next part why actually it's so efficient to interfere the schema. And then AVRO has only 1 job doing loading, and it takes around 2 seconds. What I would like also to show you is the SQL, but before we're gonna jump into it, just to make a short summary what we saw now. So basically, we saw that the loading time in Spark UI is basically split into something called loading or metadata, or inferring the schema, concretely said, and then the actual loading process. And we saw for all files except of AVRO, we have a separate job, or for CSV within the sphere schema, even 2 more jobs to do this activity. And then we can see that, okay, here we have like around 40% of the time for the metadata loading. Here we have around half of it to load the data when interfering with the schema. Parquet also, it's 50-50. And then for AVRO, we don't have a separate job here in this case for any metadata interference. And now let's have a look into SQL data frame, because for Parquet at least, you can get here also some more statistics which might help you. So that's a view which we're gonna use a lot in the next parts when you're coding. So I just want to introduce it. So what you can see here is a scanning, and then basically the actual loading of the data. So what it says here is we are reading 8 files. So we get all the information which we need. We get here the size, which we checked manually in the Explorer before. We also get some scanning time statistics. So it tells me 1.3 seconds is around what we needed for the metadata. I'm surprised that it's a little bit deviate. I think it's a total time here. Exactly. And then we see like which data actually has been loaded. So we see 10 million of rows have been loaded, and 10 million rows also have been scanned. And just to compare it, let's do it for instance for AVRO. Here we don't see all the statistics, but we can still see, okay, number of files, so 8 partitions in this case as well, 10 million of rows, and we have a size of 68.7 megabytes, which is loaded. And it seems like, okay, Parquet has some additional options which can be analyzed and also used later on. And of course, we're gonna discover it very soon. And with this, I would like to summarize our observations today. So what we evaluate is and saw AVRO and Parquet seem to be highly compressed. Of course, we saw a significantly smaller data size than for CSV and JSON. Despite compression, which we observed, the writes are quite fast, partly even 50% faster, especially for AVRO, and reads are also significantly faster than for CSV and JSON. And AVRO writes even, small typo, writes even faster than Parquet though. So Parquet and AVRO seem to provide the schema correctly. That's also really important for us. CSV and JSON don't, and we also realize in JSON seem not to understand timestamps and dates. And Parquet seems to contain metadata, which we saw in the additional scanning activity. It didn't need too much time, so there might be some metadata in the Parquet file, and this we could also observe in the SQL tab. And CSV and JSON have a preliminary job for interfering in the schema, so that's also the reason why it takes so long, because we saw like there's also a significant time for interfering in the schema, and then AVRO provides a schema correctly without any preliminary job of what we saw here. And with this, thanks a lot for listening today. I hope you enjoyed the series. If you want to see more videos like that and also continue with the series of how to loading data efficiently, you should find here below a red button where you can just click and subscribe the channel. And with that, stay tuned for the next episode.